All right, let's dive in. If you're getting ready for the CBSE physics exam, you know AC circuits can be a real game changer. So instead of just another boring revision, think of this as your secret weapon, your battle plan to absolutely crush this topic. Let's get to it.
Seriously, just imagine for a second. What if you could peek inside the examiner's mind, knew all the patterns, the favorite questions, and the little traps they love to set every single year? Well, guess what? That's not a fantasy. It's exactly what we're about to do. We've done the heavy lifting for you. We literally went through 72 past papers and crunched all the data. We've basically decoded the DNA of the AC circuit section. This isn't guesswork, my friends. This is your data-driven inside scoop. Okay, so our first mission is all about focus. We are not, I repeat, not going to study everything equally. No way. We're going to target the topics that give us the most bang for our buck, the ones that show up over and over again. This is your high-frequency hit list.
Whoa, okay. This right here, this is probably the most important secret in the entire chapter. Just look at that chart. A massive 15%, half, of all questions are on series LCR circuits. This one topic is literally worth as much as everything else combined. If you want to study smart, this tells you exactly where the battle is won or lost.
Let's be absolutely crystal clear on this. If you can walk into that exam hall with a rock-solid, unshakable understanding of LCR circuits, I'm talking impedance, resonance, phasors, the whole shebang, you are already halfway to a fantastic score in this chapter. It's the number one thing you can do, period. Okay, so now we know what to study. That's step one. Now, let's level up and talk about how to study it. See, it's not just about getting the right number. It's about presenting your answer in a way that makes the examiner want to give you every single mark. You've got to get this into your head. This is the big mindset shift. Those super fast numerical shortcuts that you might use for competitive exams like JEE, they can actually hurt you here. The CBSE board wants to see your thought process. They reward detailed, logical explanations. And here it is, the golden formula for your answers. Seriously, just follow these 4 steps for every numerical problem. 1. State the principle. 2. Write the formula. 3. Show your work clearly. And 4. Finish with a nice concluding statement that, and don't forget this, includes the correct units. It's a simple recipe for success. And while you're writing those perfect answers, make sure you're speaking the examiner's language. These phrases here, they're not just jargon. They're like secret code words that signal, hey, I actually get this. Sprinkling these buzzwords into your answers shows a level of mastery that graders absolutely love to see. Let's make this super practical. Check this out. On the left, you've got the shortcut answer. Yeah, it's technically correct, but it's lazy. It might get you 1 mark if you're lucky. But now look at the right side. That's the beauty. It follows our 4-step process, it uses formulas, and it explains the why. That, my friend, is a full marks answer every single time. All right, final section. We know what to study and how to answer. Now, let's talk about what not to do. These are the most common traps that students fall into year after year, and we're going to make sure you sidestep them like a pro. This one is a classic. You have to remember, reactance, that's X, is the opposition from just the inductor or just the capacitor. But impedance, that's Z, is the total opposition of the entire circuit, including the resistor. They are not the same thing. Don't mix them up. Oh man, another huge mistake. When you're calculating average power, you absolutely must use the RMS or effective values for voltage and current. If you use the peak values, your answer will be wrong. Why? Well, because the actual work done by the circuit, like lighting a bulb, depends on this effective value, not some momentary peak. Let's break that down. So what on earth is this RMS value? Just think of it like this. It's the AC voltage's DC twin. It's the amount of DC voltage that would produce the exact same amount of heat. And the rule to remember is super simple. To get from the peak value to the RMS value, you just divide by the square root of 2. That's it. Okay, this is a big one for showing you really understand the physics. It's not enough to just say current leads voltage in a capacitor. You have to explain why. For a capacitor, think about it. The current has to flow first to build up charge. That buildup of charge is the voltage, so of course current comes first. For an inductor, Lenz's law creates this back EMF that fights the current, making it lag behind. That's the deep physical reasoning they want to see. And if you ever have a brain freeze in the exam trying to remember who leads who, just remember this awesome little trick. Eli the Iceman. In an inductor, L, voltage, which we call E, comes before current, I, Eli. In a capacitor, C, current, I, comes before voltage, E, ice. It's a lifesaver, trust me.
So if you take away just one thing from all of this, let it be this. The CBSC exam is not just a math test. It's a communication test. They want to see that you truly understand the physics, not just that you can plug numbers into a formula. Show your thinking, explain your reasoning, and the marks will follow.
So there you have it. You have the complete strategy. You know exactly what to focus on, you know how to structure your answers for full marks, and you know the common traps to avoid. You have the entire playbook. The only thing left to do is put it into action. And don't worry, we're going to help with that too. Keep an eye out for our very next explainer, because we're going to tackle a special 15-question quiz designed to test everything we've talked about today. We'll apply every single one of these strategies to real exam-style problems. So I'll leave you with this one question. Are you ready to make that shift? To go beyond just crunching numbers and getting an answer? And to start truly explaining the beautiful physics behind it? Because that right there is the real key to acing this exam.